Hey, welcome to The Explainer. All right, today we are going to crack the code on your electricity bill. Seriously. By the end of this, you'll not only get what you're being charged for, you'll know exactly how to calculate it yourself for any appliance you own. So let's dive right in.
You know, we've all been there, right? You're looking at your bill and you see that mysterious KWH. What is that really? It kind of feels like a secret language, but I promise you, in just the next few minutes, we're going to make you fluent in it.
Okay, so kilowatt hour. It sounds super technical, doesn't it? But it's actually incredibly simple. Here's the easiest way to think about it. Kilowatt is just how much power an appliance needs to run, and hour is simply how long you use it. That's it. How much power for how long.
So, the whole thing, it really just boils down to two simple steps. Step 1, we figure out the power an appliance is using, and we measure that in kilowatts. And step 2, we just multiply that power by the number of hours we used it. That's the whole game.
Okay, so for that first step, calculating the actual power, we're going to need a few ingredients. And don't worry, these are way easier to find than you might think. Let's take a look at what we're working with. All right, first up, you've got voltage. Think of it like electrical pressure, right? Pushing the electricity through the wires. Then you have current, which we measure in amps. That's basically how fast that electricity is flowing. And then there's this third piece, one you might not have heard of before. It's called the power factor. So, what on earth is this power factor thing? Well, this is probably the one new ingredient for most of you. And all it is, really, is a measure of how efficient a device is. So, for example, something really simple like a toaster or a basic heater, they're almost perfectly efficient. So they get a power factor of 1. Easy. But things with motors in them, like your fridge or a fan, they lose a little bit of that efficiency. So their power factor is a little lower, usually somewhere around 0.85. All right, so we've got our ingredients. Now we just need the recipe. And it turns out there are actually two slightly different formulas we need to know. One is for the stuff in our homes that uses single-phase power, and the other is for those big, heavy-duty machines in factories which use three-phase power.
So if you look at these two formulas side by side, you'll see they are almost identical. For both of them, you just multiply the voltage, the amps, and the power factor, and then divide by 1,000. The only difference, the only one, for that heavy industrial stuff is you multiply by one little extra number, the square root of 3, which is, about 1.732.
Okay, enough with the theory. Let's actually put this into practice with a real-world example. We're going to start with a pretty typical household appliance, something that uses that single-phase power.
All right, so let's set the scene here. We've got an appliance, it's running at 240 volts, and it's pulling 10 amps of current. It's got an efficiency, a power factor of 0.9. And our goal is to figure out how much energy it chews through in 3 hours.
Okay, step 1. We just plug our numbers right into that single-phase formula. So that's 240 volts times 10 amps times our 0.9 power factor. We divide all that by 1,000 to get our answer in kilowatts, which comes out to 2.16 kilowatts. See? Step 1, done.
And now for the super easy part, step 2. All we do is take that power number, the 2.16 kilowatts we just got, and multiply it by how long we used it, which in this case was 3 hours. And boom, there's our answer, 6.48 kilowatt hours. That number right there, that is the exact amount of energy your power company is going to bill you for. Simple as that.
Okay, so we've totally mastered a regular home appliance. Let's level up a bit, shall we? Let's tackle one of those bigger three-phase industrial motors and see how that other formula works.
All right, so for this big motor, the numbers are definitely bigger. We're talking 400 volts, 20 amps. It's got a pretty typical motor power factor of 0.85, and it's been chugging along for a full 5 hours.
Okay, let's do step 1, but this time with our three-phase formula. We're going to start with that special number, that 1.732, remember? And then we multiply that by our voltage, our amps, and our power factor. Then divide the whole thing by 1,000, and we get a much, much beefier power rating, around 11.78 kilowatts.
And now for the final step, step 2. We just take that power number, 11.78 kilowatts, and multiply it by the 5 hours the motor was running. Pretty simple, right?
And there it is, 58.9 kilowatt hours. Wow. You can really see how fast the energy usage scales up with that heavy-duty industrial equipment. I mean, that's almost 9 times the energy of our little household appliance. And just like that, you get it. You now have the formula. You have the understanding. You can actually decode your own electricity usage.
It's not some big mystery anymore, is it? It's just simple math.
Look, if you forget everything else, just remember this one core idea. Power, measured in kilowatts, multiplied by time in hours, equals the energy you pay for in kilowatt hours. It always comes down to how much power something uses and how long you leave it on.
So I want to leave you with a question. Now that you actually know how to do this, what's the first thing in your house you're going to calculate? Is it your gaming console? The air conditioner? The refrigerator? The power to know is literally in your hands now.